Hey, here's Mr. Anderson with another Frappy Dappy Doo. Woo woo. This is number 2 on, the thing I handed out in class. Anyways, here we go. Directions show work, indicate clearly the methods you need to use, etc., just like normal. Okay. A simple random sample of 9 students was selected from a large university. Each of these students reported the number of hours he or she allocated to studying and the number of hours allocated to work each week. A least squares regression, a linear regression was performed, and part of the resulting computer output is shown below. So here is the data. The scattered plot below shows the data that were collected from the 9 students, and it looks like, there's no question on this page, so I guess it's on the next page. Let's see. After point P, labeled on the graph on the previous page, was removed from the data, a second linear regression was performed, and that computer output is shown below. Okay, apparently there's this point P. There it is. Point P is being deleted, apparently. So, it's just saying what happens to all the stuff in the table. Well, if you remember, the stuff in the table talks about what the linear regression is. That's what these two things. This is the A value and that's the B value. The other things we've looked at so far are the standard deviation and the R squared, right there. So I guess we'll be comparing mostly those things, but just kind of like an overall gist of what's going on. Like, if I was to try to draw the line of best fit with P, then because it's like all the way over here, it seems like there would be a line kind of like that to be where it would probably be. So, there's points here going back and forth, and there's one over here. So this is a line that kind of goes through it. And this would have to deal with the R value, the, correlation coefficient to see if it was a good fit. And it looks like it was bleh. It was bleh. 47% is not very good. Like, for this question, you don't really have to find R, but just to show you, 0.476, oops, I need to do the square root of that. If you found the regular R value, that's like a 69%. That's moderate at best. So it's not very strong. If we were to take P out completely, then this over here is very scattered. Saying that this is a line of best fit is blah, 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 even worse. So more than likely the R value or the R squared value is going to go down. So it was 47. I'm sure on the next table it's lower than that. Yeah, it went from 47 down to 2. So that's very important to notice. The R squared value does go down. R squared goes down. Hey, look. Next block started. So does it have a large influence? Yes. The answer is yes. I'm explaining right now, I guess. I'll just write myself a note. It's yes. So that's one of the things that's going to differ. It's definitely probably going to be the most important. Oh, gosh.
This begins Raj Reed. We should be tucked away in Raj Reed. Thank you.
Well, that's unfortunate timing. I'm going to read these questions and okay, don't tell. Okay, so other things, standard deviation honestly isn't going to matter that much. I mean, I'm sure it changed. Yeah, it didn't even change that much, 4.3 to another different type of 4.3, so that doesn't matter. B's probably changed some over here, because with the P, it's definitely going to be positive. Like, you can just see it. This is going to be a positive R value. But if you take it out, then I don't know. Maybe it's positive, maybe it's negative, right? Who knows? It's horrible either way. So what was this? 8.1 and 0.49. 8.1 and what was it? 4.9? No, 0.49. So those changed as well. let's see the constant. So this would be 11.123 plus 0.15x. That would be the regression. So it was an 8.1, so now it's an 11. So like the intercept went up, the slope the slope also went down a little bit. So those are things you can say. Does it have a large influence? Yes. For the most part, the r squared value went way down since the p made it look more linear, but without it, it appears much more scattered or something like that. Let's see, the r squared went way down, okay. Since the p made it look more linear, without it appears much more scattered. Okay, so that's definitely the big thing. I'm sure you could mention the other things and it would be fine. What was it? The y-intercept increased from 8.1 to 11.123 or something like that. And the slope also kind of got flatter. It decreased. Slope decreased from 0.49 to 0.15. Just put zeros there to make it prettier. But I'm telling you, the big thing is the r squared. It makes it a lot less strong. That's the big thing. Okay, the researcher who conducted the study discovered that the number of hours spent studying recorded by the student represented by P, which used to be up here, was recorded incorrectly. The correct data point for the students represented by Q, which is, oh boy, all the way over here. Explain how the least squares regression line for the corrected data in this part would differ from the least squares regression line. So, I mean, that should mean that all the other points are the same from here. It looks like a little bloop bloop. Yeah, it's a little bloop bloop. Those are all the same. So when P was up here, it definitely made like that going that way. But now that it's down that way, it's going to have to go down like this to reach that Q. So now the regression, instead of having a positive slope, it's going to have a negative slope. And I'm guaranteeing that's going to be the thing they're looking for the most. They want you to know that the least squares regression line is going to have a negative slope. And we're going to have to use context, definitely use context for this part. Explaining how it would differ. Okay. The least square regression line would change from having a positive slope to, I'll just write now, a negative slope out of paranoia. That is the number one thing right there. Yeah, I guess if I wanted to do context, it'd be like, instead of more work means you're spending more time studying, it would be, if you work more, that means you're studying less. Actually, honestly, I'm not sure you need context for this. Explain how the least squared regression line would differ from the last squares regression line. But I might as well put it, because why not? Now, the more you work, the less study time is predicted. Do make sure you put predicted if you're writing this at all. Non-deterministic stuff. Okay. That should be it. Like, if you remember, the three things you're supposed to talk about are strength and direction and form. The thing is, the strength, it's still scattered. The strength's going to be about the same, so it doesn't really matter that much. Form, it's still not really looking that linear at all, so that's the same. It's the direction that's changing, and because that's the only one that's changing, that's definitely what they want you to talk about. So explain how the correct data would differ. That's the one, the differ. The strength and the form would stay the same. Okay, looks like this is a different question. I'll just keep going. The Great Plains Railroad is interested in studying how fuel consumption... Actually, no. I'm going to make a different video for it. Changed my mind. Okay. Take care.